Live from the North Carolina Museum of Natural Sciences in beautiful downtown Raleigh. It's the Science Cafe with your host, Chris Smith.
Good evening, everybody. Hi, welcome. Thanks for coming out to the museum tonight. My name's Chris. It's great to see all of you out here at our weekly Science Cafe. How many of you have been to the Science Cafe before? Yay, welcome back. Thanks for always coming out to our cool events. If this is your first or maybe only your second or third Science Cafe, welcome. Thanks for coming out, being a part of the activities that we do here at the Museum of Natural Sciences. In fact, I saw a few of you earlier today, too, when our paleontology team announced a new dinosaur. Hi, folks. Thanks for coming out, spending so much time with us. Yeah, we're here in the Daily Planet Cafe every Thursday night, meeting scientists, engineers, mathematicians, interesting people doing really interesting work. Bring them here into the cafe and then see what's going on in the world of science and learn a little bit about how it applies to our daily lives. And in tonight's case, how many of you were a baby at some point? Okay, well then this applies to everybody, doesn't it? At least a little bit. Tonight we have with us Dr. Julie Daniels from the UNC Gilling School of Global Public Health to talk about some interesting stuff. We've been chatting before the show, and I kept thinking, like, there's this incredible, invisible world of chemicals and things that are around us all the time that we really don't think about. Like, you don't think about what's hanging out on your pillow when you go to sleep at night. You might be, but in general, right, might not be something that we think about. But these things that are all around us can have impacts on us, have impacts on our health. There's a lot going on that we don't see with our eyes, but that impacts us. And fortunately, there are people who are thinking about it, people who are studying and helping to shed some light on what's going on all around us. And hopefully, like tonight, educating us, giving us a little bit of knowledge, because we know knowledge, at least in some ways, is power. So, who's ready to get powerful? Yay. But that's what we're going to do tonight here at the Science Cafe. And then after the presentation, we're going to take your questions. So as we're going along, put a pin in any thoughts that you have, and then we'll be moving around with microphones to take everybody's questions, and we'll get as many questions as we have time for tonight. But let's get to learning this Thursday night here at the museum, and welcome to the stage, Dr. Julie Daniels.
Okay, thanks. Thanks for having me. The light is really bright. Okay, so we're going to talk tonight about chemicals in our environment and how that impacts children as they develop, primarily from the time of pregnancy into early childhood. Did you want to say something? Oh, hold the microphone higher. Okay, thanks. I'll probably forget, and I talk with my hands, so I'll probably move it around. I'll try really hard to stay still. One of the things as we set this up that I want to note that's different about what I'm going to talk about tonight is I'm an epidemiologist, and epidemiologists observe the world around us and measure things around us and then think about the probability that what we're seeing might have impact on some various outcome. When we think about science, often we think about an experimental design in which we have a lot of control over an exposure, and we can measure whether an exposure in a dose-response manner has a particular impact on a health outcome. Unfortunately, when we're talking about pregnant women and little babies, we cannot expose them, well, not unfortunately, but we don't expose them to chemicals to find out what happens to their development and their health. And so what we tend to be doing instead is looking at chemicals that are already all around us in our environment and assessing how safe or harmful they might be at the levels in which we're exposed to on a daily basis. And so that's what I'm going to talk about today as we kind of work through this. And I'm not going to show a ton of data. I'm going to talk a little bit more conceptually, but I'll show a little bit of data as we move along. So I'm going to focus primarily on infant and children's health. And I wanted to show this diagram to sort of show that it is a bit of a continuum, because we start with a mother and a father, and in order for us to end up with a baby, we have to have a conception. And so all of the chemicals on the left side of the screen, and many, many more than that, can impact the ability to conceive. And so we have to get past some initial threshold in order to sort of get to the point where we have a conceptus that starts the pregnancy period to end up with a baby. And I know that you all know this already, but I just want to remind us that we're really starting back at the time of conception, and perhaps prior to conception with exposures that men might be exposed to, but I'm going to be primarily talking about exposures during the pregnancy period tonight. And then as we move through the pregnancy period, many things go right and result in a happy, healthy baby. But along the way, there are various points at which several things could come up, such as a congenital anomaly or a birth defect. You could be born early, you could be grow poorly, and all of these things can sometimes have cascade effects as you grow into a child and have sort of consequences. So I just put this here to sort of point out that we are on somewhat of a continuum, and some of these outcomes that we might talk about or think about are competing with each other, because you have to at least be conceived in order to be born. And if we can't ever get to conception, then we're stuck way back with the environmental exposures preventing conception. But we're going to talk about after we get to that point. And we start with two cells. We start with a sperm cell and an egg cell, and at conception, we're really just two cells. And within a 2-week period, we go from these two cells to this pretty large cluster of cells that create a neural plate. And that's in the very top panel here on the left side. You see that circular disc. So that is what we all look like at 2 weeks old. And that little line coming up through the bottom of that, I don't know if I can get the pointer right here. That is the neural crest. And that becomes your neural tube, which eventually becomes your spinal cord and is the beginning of your nervous system. So in a 2-week period, we go from two cells to a bunch of cells that have the beginnings of a spinal cord. And from that period, at the 3rd week of conception, after conception, to the 8th week, you go from looking like a cluster of cells to what we can recognize as a baby. So in that 5-week period, from 3 to 8 weeks, a lot happens, right? So there's a lot of organ formation. All of your systems begin. I'm telling you this because a lot of stuff could go wrong during this point. There's a lot of cell division and differentiation. It's a really rapid period of development, and a lot of things have to go right, and usually do, for us to get all the way down to the 40 weeks delivery. But in this 5-week period from 3 weeks to 8 weeks, that's when all the organ systems are formed. Okay, so that's a critical period of development at which, if you're exposed to something bad, you could really induce a problem. And we know this because in studying folic acid during pregnancy, this neural crest that I'm talking about here, this ends up closing into the spinal cord, which I mentioned before. When that doesn't happen properly, we end up with neural tube defects, such as spina bifida or anencephaly. We know that happens on day 22 to 23 of gestation. So if you insult the system during those days, you end up with that sort of birth defect. So it's that precise when we're talking about certain systems. But when we're talking about the brain development, we go from this period at 8 weeks all the way to delivery and then beyond into the first few years of life. And the brain is developing during that whole period. So it has a much longer period of differentiation and development. Thus, it has a much longer period of vulnerability to risks that might impact or adversely affect its development. So once the baby's born, so I meant to say that although I've cautioned you that so much could go wrong during this period, most of the time it goes right. And it's a pretty resilient system when you think about all the things that have to go right to make this happen. We actually, it's kind of amazing that it happens right as often as it does. And so when we get it right and we get a baby at the end, we still have this period of heightened vulnerability to external insults. And babies, as you all know, we think of them as vulnerable because we take care of them. They can't do very much for themselves. But for more reasons than that, they have an underdeveloped immune system. They have an underdeveloped detoxification system, an excretion system. And their skin is thinner and more permeable than our skin as adults. So they're at a heightened vulnerability during their infancy to exposures in their environment as well. They also, because of the way that they exist in our world, their positioning in our world puts them at heightened vulnerability because they're often on the ground, on blankets, or in little carriers sitting on the couch, and they're exposed to all the dust that settles in those places. And so I'm not trying to scare everybody and make everybody feel nervous, but babies just have more opportunities to get exposed to stuff because they're in the same place with all this dust settling, and they then crawl around on that space and put their hands in their mouths, right? So we think of them as little germ factories. When they're sick, we all get sick, but really we're like creating this dusty environment for them, and they get all the stuff that's in our air settled up for them to ingest. So babies are vulnerable from the time that they're conceived all the way through childhood. And then the mom provides this protective place for the baby. So in utero, they're protected with the placenta, but the placenta offers nutrition, but the placenta can also be permeated by environmental chemicals to insult the development of that baby. And then after birth, the mom often breastfeeds, and so that provides a source of nutrition, but it can also carry chemicals in the breast milk. So from the time of conception through early childhood, we have all these opportunities to sort of insult this system. So it's surprising that we're here at all, right? At the brain, I mentioned the organ development, but the brain is sort of this longer period of development. So it also begins in early gestation to develop, with myelination sort of continuing through early childhood. And then around 2 years of age, there's sort of this programmed cell death by which we sort of clear out all the clutter of the nervous system and sort of end up with our final number of neurons. But you can see that from the time of birth, the density of and differentiation of the neural structures increases quite a lot in that first year as far as what's available as far as neuron density. So we think of this as what's going on inside the brain, and what we observe outside is sort of this continuum of both behavioral and cognitive development. So most of us fit somewhere on this bell curve of development. We're right in the middle. We sort of have average, right? We all kind of want to be average. Or we have some people at the very high end of the intelligence spectrum, and then others who have more deficits or more problems. But we think of this as sort of a continuum in the population that at any point during this time period could be insulted by either a chemical exposure or an injury, anything that could disrupt the system. And the timing and the intensity at which it's disrupted might impact the severity of any kind of adverse effect that we would see from this. So if it's subtle or brief, you might not see any adverse effect, but if it's continuous or very intense, you might see an adverse effect, and you might see it somehow shift from this someplace on this normal spectrum to another place on this normal spectrum, or you might see it shift into this place of impairment where we're really talking about problems at the problematic end of development. A lot of the work that was early work that was done on the risk of environmental chemical exposure during pregnancy in relation to how children's brains development was done by Dr. Herbert Needleman, and he was studying lead. And we know now that lead is a neurotoxin. And he was studying this at the population level. So we're not studying individual children, we're studying children in a larger population. And we know that in the population, most people, the average IQ is around 100. So most people are going to sort of be right in here. So in a low lead population, you'll have the average IQ around 100, and then you're going to have some people who have higher IQ and some people who have lower IQ. When you expose a whole population to lead, we're not talking about insulting one individual, but a whole population, you're affecting all of the people in that population, right? And you're going to shift their IQ points, so everybody's got a few IQ points fewer than they would have had under an alternative model by which they were not exposed to lead. So here's where we might all be if we weren't exposed to lead, and then we all drop a few IQ points with exposure to lead. For most of us, nobody would know the difference, right? We're not going to know whether we were a few IQ points short from what we were expected to be at the individual level. But at the population level, what that does is it shifts a lot more people into the tail end of that distribution that we consider problematic or impaired. And so we're impacting what we think of as individuals at the population level, that this many more people need assistance to sort of get through their daily life. So I'm showing you this to show you that we're not talking about dramatic effects. If you're exposed to a little bit of lead or a higher level of lead, we're not talking about the fact that you're going to fall over and not be able to exist. We're talking about you'll have some subtle damage to your brain. And at a population level, when we look at that, that shifts the whole population just a little bit to the left. Okay, so I've given this example with lead. We think about this with lots of different chemicals, and some chemicals we know when we're exposed in high doses, we cause really dramatic effects. But a lot of chemicals we don't know very much about. And there's a lot of things besides chemicals that impact infants' health and neurodevelopment, including genetics, including the prenatal environment with respect to maternal hormones and nutrition, including the timing at which that child is born, and including the social influences that happen after delivery, both positive and adverse influences. So we can make up a lot of points when we provide an enriched environment, and sometimes what we might have observed as a deficit wouldn't be observed because we've recovered by having an enriched environment, either nutritionally enriched or socially enriched. But when we come to chemicals, we sort of have this laundry list of things, because chemicals are all around us. Like, everything is a chemical, right? They're everywhere, and most of them are here, or many of them are here for a good reason, right? And nutrition is a chemical, medicines are chemicals, so many of them are here for our benefit. But there are some things that we know are not good for a developing baby, including alcohol, tobacco, metals, both lead, mercury, arsenic. All of those we know there's not really a whole lot of good that can come of those with respect to an infant's brain development. There's some that we don't know as much about, like pesticides or air pollution. We know that there are several medications that are known to have adverse effects during early development, including the prenatal and the early postnatal period. And there are nutritional factors that we know we can have too much or too little of that can impact development. And then there are these things called flame retardants and plasticizers and waterproofers. And I'm going to talk more about these today. So these are chemicals that we have introduced into our environment to serve a purpose for us in the production of things that we use every day. So they have a purpose. They've been introduced for that purpose. But now they exist ubiquitously in the environment, and we don't have very much information about whether it's okay that they're there, but they don't go away very readily. They're persistent. They don't degrade. So the flame retardant and plasticizing chemicals are additives. They're added in the production process to a lot of products, and they're added for the purposes of reducing flammability. And this started in the 70s because industry felt it was important to reduce the rate at which textiles and different products burned, and it was for consumer safety. So these chemicals now, and I'm going to talk about two classes of chemicals today, the polybrominated diphenyl ethers, PBDEs, and the organophosphate esters, OPEs. And there's many more chemicals that sort of fit in this broader class of chemicals, but I'm going to focus on those today. And when you look at the products that are on the screen, They're in all of these products. So what they do is they are added to the production of the foam and the fabrics that we use in our furniture, in our drapes, and in our carpets in order to reduce the flammability. But they're also in electronics because electronics heat up. So our computers and our cell phones and all of our things that we love so much, they heat up when we use them. Don't get scared and like throw your stuff away. But the point being that they are all around us and they're there for a reason. They are also used as plasticizers, and so they're readily available in a lot of plastics, including the toys that our kids play with. So I'm not trying to be alarmist, but I'm just trying to raise awareness that these are there. They've been there for a long time, and we don't know very much about them. So the polybrominated diphenyl ethers, the PBDEs, so the flammability standards came into place in the 70s, and around the late 90s, it started to become observed that these were not degrading, they weren't going away, and they were becoming ubiquitous in the environment. So that's always concerning because you don't want things to just hang around indefinitely and not degrade. It was also observed that humans were being exposed. So when they were sampling humans, they were finding that they could measure these things in our blood, in our urine, and in our breast milk. And the thing that people started to become worried about was that these chemicals, and there's a bunch of them. I'm showing just one chemical structure here on the left, but they're structurally somewhat similar to thyroxine, so a naturally occurring thyroid hormone. And when we have chemicals that mimic hormones in our body, we worry that they might replace that chemical in a way that would cause that chemical's thyroid function to sort of be aberrant or problematic and have downstream effects on what the intended purpose of the natural chemical should be. So, and then around early 2000s, there was a voluntary reduction of use of these chemicals because there was sort of growing concern that they existed. And there still wasn't very much data on whether they did anything bad, but we just didn't like the fact that they were persistent in the environment. So there started to be some studies in animals and in cell lines that were looking to see whether they did anything to humans, or did anything at all, not necessarily to humans, but there weren't very many studies in humans at the time. So there was some experimental data that showed that, yes, they were there, and they didn't look horrible, but they didn't look great either, and we should probably be taking a look in humans. And part of the concern was that they were endocrine disrupting chemicals. They were impairing the endocrine hormones that we have they were mimicking the endocrine system in our body, thus they were similar to the thyroid hormones. And this is important in neurodevelopment, in our brain's development. So we were curious, and a couple of other groups were curious around the same time, of studying the fact that these chemicals existed in humans and how high the levels were and whether they were impacting infant development. And there were a couple of studies that showed that there was some impairment in cognitive development and some that showed that there was some impairment in behavioral development. So we decided to look at this here in North Carolina, and with the idea being that we would try to be looking at maternal exposure during the prenatal period. We know these chemicals can cross through the placenta and reach the developing fetus, and they could either have, I can't see these very well, a direct neurotoxic effect and work through pathways that directly affect the developing nervous system to impair neurodevelopment, or they could work through an endocrine disrupting pathway, and I might be putting these upside down, I can't see this very well, but and impair the endocrine system and thus impact brain development of the developing fetus. So how we do this in real life, because we can't assemble a set of individuals and assign half to exposure and half to not exposure and see which fare better, we have to observe this. So we did this by looking opportunistically at women and children who were enrolled in this study in UNC Hospital. So the study was called the PIN study, the Pregnancy, Infection, and Nutrition Study. And this study enrolled women during early prenatal visits, so in the first trimester. And it was originally set out to look at preterm delivery. And so we were taking advantage of the fact that these women were being followed throughout their pregnancy for their risk of preterm delivery. They were providing urine samples and blood samples, and they were answering all sorts of questionnaires and let us look at their medical records to get information about the health of their pregnancy. We followed the women during the first year postpartum and enrolled their babies into our study. And we went to the home at 3 months, 12 months, and 36 months to assess the development of the babies and weigh them and measure them and do all kinds of stuff. So the original study was pretty large, but we didn't get money to start our kids' follow-up study until the last year of this original study. So these babies that we studied were the babies that started off in this pregnancy cohort study. And then we were able to follow them from the time the women were pregnant through the time the babies were 3 years of age. And there were about 350 of them. And they were born sort of 2004 to 2006. So then when we're in the home, we give the mom some questionnaires to fill out about the babies. And so the mom is rating the child's behavioral development with an instrument that we had called the Behavioral Assessment for Children. And it asks about all these different things that babies do or children do, and how their emotional and behavioral development is sort of relative to what the mom expects. And then our staff go ahead and assess the cognitive development of the babies. And so what we get is what you might think of as an IQ score. We don't call it an IQ score when we're talking about 3-year-olds, but we call it a cognitive development score, which considers their fine motor activity, their visual reception, how they express and receive language cues. And so we're able to sort of give this baby a score that's kind of like an IQ score, and it's normed. And so there's a middle, a bell curve, and some are at the high end and some are at the low end. And a behavioral assessment, which kind of identifies aberrant behavior. And we know that all 3-year-olds are hyperactive and that all 3-year-olds throw temper tantrums. So what we're looking for are things that are aberrant besides being 3 years old. So I want to tell you about who's in this study because I think it kind of matters. These are women from UNC Hospital. So they're pretty healthy. They're pretty well off. Their average age was 30. Their average education was college education. Their average BMI, nearly 60% of them had normal BMI. About 30% were overweight. And we had a little bit of a funny sex. About half of them were first pregnancies. And our sex ratio was slightly biased towards boys for some reason, but that's what we got. So I'm going to show you just a few results from this study, and these are looking at what we did was I forgot to mention this, we collected the women's breast milk, and these brominated diphenyl ethers, these are lipophilic substances, so they hang out in breast milk because breast milk is really fatty. So that made it really easy for us to measure it because we didn't have to stick the women and draw blood. They were just able to give us a little vial of breast milk, and we were able to measure these chemicals in their breast milk. And so what was important to note about this is that 85% of the women in our study breastfed. So that's a pretty high ratio, which also tells you a little bit about perhaps the uniqueness of this sample. They were a pretty high breastfeeding sample. So what we did is that we compared the levels of these chemicals, and we focused on the ones that were present in at least 70% of the women, and most of these were present in at least 80% of the women. And these are all different chemical structures that are what we call congeners of this main parent group of chemicals called PBDEs, and they're labeled by their number. So it's BDE 28, 47, 99, 100, and 153. And they're all slightly different in their chemical structure. But we look to see whether babies and the median or lower level of exposure to these particular chemicals in their mother's breast milk differed in their development relative to babies with higher exposure. And what we anticipated is that babies with higher exposure would have poorer neurodevelopment relative to the babies with lower exposure. That is not what we found. We found that the babies in our sample, compared to those with average or below levels of exposure, actually had higher scores on their cognitive development than babies in the lower half of the exposure. And that really didn't sit well because that's not what we expected to find, and that's not what the environmental scientists wanted us to find. But we controlled for all the things that we needed to control for, like parity and maternal education and SES. And that's what we found. So that's what we're reporting. What I can tell you is that these are pretty imprecise estimates because we didn't have a whole lot of people in this study. And so what I mean by that is that they're not completely stable, but the patterns that we're seeing show that the development is higher with higher exposure. When we get to behavioral development, we looked at externalizing behaviors, which are like aggression and hyperactivity, and then also internalizing behaviors like anxiety. And what we found was that there was some signal with some of these chemicals that showed like slightly higher externalizing behavioral problems. That's how to interpret these. I'm pushing the wrong button. These dots being slightly elevated over the baseline for a couple of these chemicals, but not all of them and not dramatically. And when we got to internalizing behaviors, we saw something somewhat similar. So slight elevation, but nothing really dramatic. When we look at these levels, they're higher, but they're imprecise. So, and then this was anxiety specifically. We showed that there was a couple of them that really showed some associations with the anxiety, but they're a little bit imprecise, which means we just can't completely trust them. They're not stable. So we want to do more in a bigger sample to get a better, more precise estimate. But we don't have that here. So we work with what we have, and we sort of basically concluded that, well, there wasn't a whole lot going on with cognition. There might be something going on with behavior, but we aren't really sure why we're not seeing something bad going on, because what we're seeing with cognition might be actually better. And we think it might be something to do with the selectivity of the sample, because these kids had a lot of access to lots of stuff. So if you have a lot of exposure, you might also have a lot of positive stuff. You have a lot of stimuli. You have a lot of toys. You have a lot of cushions and couches and drapes and all the things that these things are contained in. About the time that the study was going on, these chemicals were already out of production, but we became more aware that this other group of chemicals, the organophosphate esters, were becoming more readily used as a substitute for these chemicals that have been phased out of production. So because of the concern about the persistence of these chemicals, and because the industry was still required to retard flammability in their products, the chemical industry introduced a new set of chemicals, these OPEs, instead. And what we were able to, so then around this time, let's see, Cooper measured a bunch of sofas, the foam in sofas, and found that yes, indeed, before 2005, you saw a lot of these brominated chemicals. And after 2005, you started seeing these other chemicals show up in the products. So basically, we're just noting that we've replaced these chemicals with these chemicals. So what do we know about these chemicals, right? Well, we know that in humans, over this period of time, we could see that they are increasing in humans. So it makes sense that if they're in the environment, they're also getting into the humans. Does it matter? Does it do anything bad? We don't know yet, right? At this time, and still now, we don't know very much about these chemicals. Most of what we know comes from zebrafish models. And the zebrafish models tell us that these chemicals have a lot of endocrine activity. And we don't like chemicals that have endocrine activity because endocrine activity can impair brain development. What we know in humans is very, very limited. So there have been a couple of studies that have shown that so again, when I talk about this set of chemicals, there's a bunch of different chemicals that sort of exist within this broader chemical class of OPEs. So we're not talking about just one chemical, we're talking about a bunch of them, but they all kind of have these similar structures. And so some of these chemicals have been starting to be observed and shown to have endocrine activity in humans. They've impaired semen quality, semen motility, and morphology. And so we know that that's potentially impacting fertilization. But all we know about what happens once people are exposed and pregnant is from one study. So there was one study in California where they did show that two of these chemicals, DPHP and BDCIPP, have been associated with both behavioral and cognitive development. And this study just came out last year. So a doctoral student that I worked with, Brett Doherty, went back to this original study that we started with looking at the brominated chemicals and said, hey, do you have any urine left? Well, actually, a postdoc of mine, Kay Hoffman, said, do we have any urine left? And Brett Doherty said, yeah, I'd like to look at that for my dissertation. And so we did. We had urine stored. It had been stored in these freezers for millions of years, or I guess 15 years. But Heather Stapleton's lab at Duke analyzed those urine samples for these new suite of chemicals for us. And we still had all this behavioral data left over. So we looked at that data in relation to both our cognitive developmental measures and our behavioral measures. And what we found was actually what we had expected to see with the PBDEs. In relation to the prenatal urine levels of these chemicals, this baseline is sort of no effect. We saw that across all these different domains of cognitive development, these patterns, even though this association was small, showed that development was lower among those that were more highly exposed. So higher exposure was associated with poorer neurodevelopment with these organophosphate ester chemicals than those that were less highly exposed. When we looked, and I guess this was specifically more prominent for this one chemical called IPPPP, and I would say the whole long chemical name, but I always flub it up, so I'm going to say IPPPP because that's the quicker, easier term that I can say without flubbing it up. Then when we looked at behavior, we didn't see associations across the board for all of these chemicals, but we did see some associations with this chemical, BDCIPP. And it was associated with both externalizing and internalizing behaviors. And when these lines here, these are confidence intervals, don't cross this sort of baseline, we call that statistically significant in these studies. And we try not to focus solely on that. We try to look at the patterns across this. And for the most part, we don't see like super strong measures, but we do see that these are generally negative or inverse or problematic relative to the baseline for these couple of chemicals. And then this one looks a little positive. So what do we make of that? Well, we are concerned that these currently used organophosphate esters might have some neurodevelopmental impacts on brain development, both behavioral and cognitive development. But because this is an epidemiology study, this is not an experimental design where we've really carefully been able to measure everything and dose it and control for everything except for this exposure, we need to sort of think about this in the context of other studies and increasing evidence that either is consistent or refutes this study. But for right now, what we've found is that for the PBDEs, we don't have as much to worry about in our study, but that's not very consistent with some of the other studies. They did find some adverse effects, and so we have to be really careful to sort of weigh that evidence as we draw conclusions. But for the OPEs, there aren't any other studies except for one, and ours and that study both found adverse effects. So we need to kind of keep looking at that. Just a few caveats on how to interpret these data because they are observational and they aren't perfect. We do think that this was a little bit of a select sample. These were, highly selective women from UNC hospitals. They're well educated, pretty well off. They have resources, and so their kids are pretty healthy and do well. But that's everyone's exposed to these, not just people living near industrial sites. We used several scales. Some of them are parent report scales. So a parent's report of their child's development is as good as the parent's report of their child's development. It's not standardized because different parents have different levels of tolerance for things. But the parent knows the child best, so it is a pretty validated tool to use. We did do a standardized assessment with our own staff in the home, but those are always subject to how that child's performing on a given day, so it's not perfect either. And then we're able to control for a lot of factors that we know impact neurodevelopment, like nutrition and SES and education of the mom, but we didn't control for all the other chemicals that these children might be exposed to. So I still think that there's work to do, because what we have seen in the zebrafish studies, especially for the OPEs, is that these chemicals have some risks associated with them, and we need to be looking more readily in the human studies. The PBDs are already banned, but I think it's important to continue to monitor the chemicals across both of these chemical groups, because they're ubiquitous in the environment. If they're ubiquitous in the environment, they're going to be still ubiquitous in people, and we want to make sure that we're paying attention to whether they rise. I need to wrap this up, so I don't want to spend too much time on this, but I'm going to sort of finish up with this slide that these chemicals are here for a reason, right? They had a purpose. They were just to retard flames, which is a reasonable thing to want to do. But they don't necessarily come without unintended consequences. And it is important for us to be aware of that, because not very much testing has been done on all these chemicals prior to entering into the consumer products. And so as we think about the need for flame retarded products or products that have weatherproofing and waterproofing, we might think about when it's necessary and when it's overkill for what we really have to have. These chemicals don't exist in isolation. We've studied them one at a time here, but what would be ideal is if we could study them as a part of a chemical mixture, because once we have the mixtures of chemicals like they occur in reality, they have some potential for synergy that could create heightened effects on the developing nervous system. And I guess, let's see what we got here. The point that I want to leave you with here is that I think we still need more studies on this, and that's like a scientist thing always, we need more studies. But because these estimates were pretty imprecise and there hasn't been much done in the way of epidemiology focused on these chemicals, there's a lot of opportunity. There are some large cohort studies that have stored urine samples that could measure some of these chemicals and really expedite our understanding of this association. So I would look for those, and then I want us as a science society to think carefully about when we ban one set of chemicals, we know that there's another one waiting in the wings to sort of replace that chemical. And this could be a case of what we call regrettable substitution, where maybe the first chemical wasn't great, but maybe the second chemical is worse. And so I think we need to do a little bit more in the way of pre-market testing before some of these chemicals come into play. Not all chemicals are bad. A lot of them serve good uses, but I think that the more that we can know about the chemicals prior to them becoming ubiquitously available for our exposure and uptake, the better off we would be. And I think that's it. I want to thanks. There's a lot of students that worked on this with me. They're now all graduated. Kate Hoffman's now at Duke, Margaret Adjunts at Vanderbilt, and Brett Doherty's at Dartmouth. And so they're great students. The labs that did these, one is down the street at Duke. Heather Stapleton's lab did a lot of these assays for us. And then, of course, our funding agencies. So thanks.
Thank you very much. All right. So now we'll switch over and take your questions. So if you've got questions, the way it'll work, raise your hand. I have a mic. Katie back there has a mic. We'll move the microphones around the room and try to get to as many people as we can in the time that we have left. Looks like Katie's got the first one.
I'd like to know what the effect of nicotine was on babies in utero. A friend of mine and I, both mothers probably both smoked. We turned into mechanical engineers. Right. Anyway, mainly interested in nicotine, not necessarily all the other byproducts of cigarettes.
Yeah. So a lot of the work that's been done on smoking's been studied for a long time, and it's been studied a lot in the relation to smoking, not necessarily the constituents of smoking. So we know that smoking creates small babies, and small babies tend to be slower to thrive than larger babies, and then it has sort of a cascade effect on brain development, primarily related to behavior as more so than cognition. But I'm speaking more about smoking as a whole, not the constituent of nicotine specifically. Yeah.
I've read in a couple of places, and I've heard it says that you need to allow your computer register tape, like, receipts from Hardee's or McDonald's, has PVC in it, and that they say pregnant women shouldn't even be handling those kind of receipts because of the fact that they could acid absorb trace amounts of PVC in their system, that could affect the unborn baby. Also, I've read in one of the magazines somewhere that they say that even a woman, if she's planning on getting pregnant, should not even take any kind of laxative, if she has a problem, because of the fact that trace amount, say for example, the brand X-Lite has been known to linger on herself for 3 or 4 months, and there have been babies born who have actually, they have born with slight defect, and found out that they had minor traces of the laxative in their own system, which they say, is this true that it can actually, change the genetical code on the baby if it passes the placenta?
So I cannot answer the question about whether the laxatives would affect the genetics or probably the epigenetics of the baby. I think that what you're getting at is, do pregnant women need to be extra careful during their pregnancy to avoid chemical exposures? And you've mentioned PVC and you've mentioned laxatives. There's sort of, you could become really obsessive about being worried about everything, and this talk probably influences that. I don't mean for it to go that way, but I'd say in general, pregnant women should try to live a healthy life, eat well, avoid unnecessary exposures, but I don't know that I would recommend that you take extreme action to sort of take everything out of your life, because these exposures are around us constantly. Yeah.
Excuse my cough. So first of all, you have my and lots of people's sympathy in needing to rely on non-experimental research designs. Yeah. But you have very good company in that. And you're right. I don't know if this is going to lead to a question. It's more a little bit of a comment, but a couple comments. But you're right to worry about the self-selected sample, especially, I think, since you seem to have left to the side parental factors. If I remember the causal diagram at the beginning, those impacts were truncated. They had their impact solely through things about the conception. I don't remember the design exactly, but they didn't push through to impacts on the children. And it's those parental characteristics that are being self-selected for. So that's one. I think I wonder if the design could be, the analysis could be changed to control in some way more fully for parental characteristics. And then the other thing that struck me is and this was very interesting, I thought, in what you had to say, that there's lots and lots of impacts at the very, very early stage of fetal development, some of which presumably lead to spontaneous abortions, so we never learn anything about those cases. And I'm wondering if some of the negative findings that you had might actually, if somehow miraculously we could take account of the rate of very early fetal abortions, they might show up there.
No, I think you're very insightful because you're correct. So in response to your first question, the control for parental factors, I didn't say it, and I should have. There was a list at the bottom. We actually did try very hard to control for influences from the parents that we knew could impact the developmental environment with regard to the parents' education, with regard to the home environment. We use this scale called the home score, which really kind of gets at parenting environment, stimuli in the home, things that you think would impact children's neurodevelopment. We tried to control for those in our analysis. I'm sure we didn't do it perfectly, and I think that there's always room. We didn't control for everything we could have. I think that the studies that found similar effects to ours for the or different effects for ours than we did for the PBDEs tended to be in more deprived populations than ours. So I think that's a potential real phenomena. With respect to your second observation about some of these babies never became observed in our study because the conceptus spontaneously aborted. We worry a lot about that in reproductive epidemiology because we know that those at the extreme end of exposure probably don't make it. And so we're only observing sort of the tip of the iceberg effect, perhaps. There's some methodological work being done, but it's really hard to sort of think about how to simulate what happens that you don't observe. And it's called a left truncation bias, and it's real. We are sure it's real, but we aren't sure of the magnitude of the impact on our results. Thanks for noting that.
So I'm curious, you've talked about using an epidemiology framework, which in my mind goes to pathogens and things like that. That's where we normally hear that word. But it works. Is there a way with, in particular, what you're studying to think about emerging chemicals, emerging pathogens, and how to get ahead of those things so that we're not following up, seeing effects, and then trying to think of ways to solve it, but getting ahead the way we do with infection and virus and things like that?
Yeah, it's a good question. So the design that I have talked about, this epidemiologic design, this is an observational study of what's already out there, right? We're not intervening with an exposure in any way. There's other designs in other models, like the zebrafish or rodent models or things like that, that might be able to distinguish risk before a chemical is released into the environment. But as far as the chemical industry, it's a pretty slow process to go chemical by chemical through all of those processes, and they've kind of expedited chemical production such that we don't always get to proceed in that way. So I think that no, there's not a great way in a human model to get ahead of it, but we do have a lot of human studies in the field now that are collecting lots of samples that could be hopefully more expeditiously mined as far as biomarkers of exposure to some of these chemicals as we become aware of them. But the number of chemicals are so infinite that it's really challenging to sort of get ahead of it.
Thanks.
I've got two questions. Forgive me. Since your study's long enough, were you able to observe the PBDE levels going down because they were no longer exposed because they're no longer manufactured? So that's one of my questions. And the other question is related to exposures to stuff in laundry detergents, particularly stuff that's supposed to stick around. And I'm thinking of optical brighteners, and if you have any thoughts on that.
So the first question was whether we were able to observe drops in the PBDEs because they should be going down over time since they were removed from production. And our study only took breast milk samples twice. We took them when the woman was lactating at 3 months, and then again if she was still lactating at 12 months. So they were all taken kind of close together or in the 2005-2006 range. So chemicals were not in production anymore, but they're still pretty prevalent in that environment. But we're not still following those families, so we can't take future samples to see whether they're dropped to now. In relation to your second question, it was about other chemicals that have other functions. It could be, there's a lot of chemicals in detergents. There's brighteners and there's softeners and there's fragrances. They all have I don't study all of those chemicals. There are people that do. There's a lot of concern about phthalates and bisphenol and other products that are readily used on a daily basis. And there is concern about the unnecessary additives in these products, but I can't speak to their risk. I think that hopefully what I've set up is a model by which we study these, and mostly to show you how hard it is, and why when you hear the news, you're never sure whether you can believe it or not, because it's not a perfect science, but it's what we've got to work with because they're already out there. Go ahead.
Okay. I assume that there are places in the world where the kinds of chemicals that you're talking about are pretty much absent from the environment. I mean, on different continents or so would it be possible for you to structure a study where, although the challenges of accommodating differences in parenting styles and cultural context and socioeconomic status and those kinds of things were much, much greater, could you figure out a way to extrapolate between those two settings and yet be working with two sets of data that were much purer in terms of the exposure to chemicals?
It's a good idea. I think that it's probably a little bit idealistic because there are so many different variables that you would have to control for. What I can tell you is that these chemicals were removed from production much sooner in Europe, specifically in some of the Scandinavian countries. So they don't have these chemicals. They have other chemicals. I mean, everybody has chemicals. Europe has been a little bit slower to release chemicals without more testing than we are here. But I think that it's really tricky to control for everything, and I think that would be a really optimal design if we could actually find it in the universe, but I'm not sure how practical it would be. The other thing is it takes a long time to collect these data and to go to these people's houses and bother them and keep track of them for years and years. And so there is eventually sort of a selection bias in who you have data, no matter what your study is, because you have to retain these people in observation for a pretty long time to get much from them. So I think all of these studies have sort of a flaw from a higher or lower degree for various reasons, either sample selectivity or confounding by other chemicals or influences, positive or negative, towards neurodevelopment. So it would be nicer if they screen these chemicals before they ever released them. But
let's give her one more round of applause. Thank you very much. All right, and hey, thanks to all of you for coming out to the Science Cafe this week. Let's see, next Thursday night, we have neuroscientist Tom Smith, who's gonna be here from UCLA, actually. So come and learn about your brain next Thursday night here at the Science Cafe. And I hope we'll see you all again here real soon. If you're new to the program and want to keep in touch with us, know what programs are coming up in the future, what topics, what speakers, you can put your email address there on the feedback form. And if you've got some feedback for us, we'd love that as well. So fill the forms out, keep in touch with the museum, and I hope to see you all again here for Thursday night programs at the museum. Good night, everybody.